It's good of you to join us here. We're going to talk about functions, and before we start, I just want to give credit and say thanks to the IB organization, because this is their question. This is a past paper question, as you can see. So I did not create this. This question was asked to me by one of my students around the world, and we're just here simply together to solve it and to help each other understand maths. Okay, so this is an IB official question. What does it say? The equation x squared plus k plus 2x plus 2k equals 0 has two distinct real roots. Find the possible values of k. Alright, so what is going on? We are having a quadratic function over here, and they say it has two distinct real roots, so it has two solutions. And they ask me what the possible values of k are. That implies already that we're looking for more than just one answer. Okay. What do I realize? When we're talking about quadratic functions, for it to have two distinct real roots, then I realize that the discriminant needs to be greater than 0. So let me write that properly on the lines. The discriminant needs to be greater than 0. Okay. What is the discriminant? The discriminant being b squared minus 4ac, and that has to be bigger than 0. Okay, so let's plug in the a, b's, and c's then to find out what the values of k are going to be, because b is k plus 2, so k plus 2 squared minus 4 times a times c, all of that has to be greater than 0 for it to have two distinct real roots. Okay, and then we simplify that. K plus 2 squared. Let me just write down that. Hopefully you realize that is k plus 2 times itself, k plus 2. Let me simplify this side. Minus 8k is bigger than 0. Okay, so please don't be one of those students who says k squared plus 4. No, because if you properly expand this now, you're going to get k squared plus 2k plus 2k plus 4, and then minus the 8k, and all of that needs to be bigger than 0. Good. Let's simplify that. Do we have some like terms? K squared, that's the only term with a square, so k squared. Then I have 2k, 4k, minus 8k, so that's going to be minus 4k. Plus 4 bigger than 0, and that then again is a quadratic expression which can quite easily be factorized. K minus 2, k minus 2 again, bigger than 0. Okay, interesting. Now if can I move that? Oh, I can. That's beautiful. Okay, let's continue, because if I write that down like this, k minus 2 squared bigger than 0. When is that true? Well, if I just make a very quick sketch for that, then when k is 2, my y is going to be 0, quadratic, so it is a parabola. So this is roughly a sketch of the function. So for which values, will you have which values of k will you have two distinct real roots? Well, that is pretty much everywhere, because even when k is, for instance, a negative, let's say when k is minus 3, then minus 3 minus 2 is minus 5, but the squared will turn it into a positive. If k is 0, 0 minus 2 is minus 2, squared is going to be a 4. So if I would extend, and this is not a very nice sketch by the way, but this parabola will roughly look like this. So when k is 0, it's going to give me 4. Alright, so everywhere I have two distinct real roots, except for one particular point, and that particular point lies over here, because there I only have one distinct root. So what is my final solution? Well, k is element of R. Okay, it can be anything or everything, except it cannot be 2, because when k is 2, you only have one distinct root. But for all the other values of k, you'll have 2 distinct roots. So that would be my answer. All right. Hopefully that was useful. You can like and share this video if it was. Otherwise, just ignore it. And you can find me on my site explainingmaths.com for more free resources. Yeah, and you can find me on Facebook and Twitter as well. And you can ask me your question if you have any. All right. I'll see you later. Bye bye.